even there yet. Alright, so today we're going to pick up with where we left off on inverses. Alright, Sammy, you know this. You know this.
Oh no.
Inverses. What did we learn about inverses before the break? What did they switch?
The Y and X.
The X and Y, the Y and X. Okay. So, inverse is just like inverse operation. So if we look at this equation, x cubed equals 27. What do you need to do to both sides of this equation to be able to solve it? Take the cubed root. We would take the cubed root. Alright, so whenever we have a cubic function, not just a cubic equation, but a cubic function, what would be the inverse of that? Well, it is the cubed root. Alright, guys, let's settle down. Whose trash is that?
That's mine. I'll throw it away.
Alright, thank you.
Okay.
So, we talked about this last week also, but I just want to show you that it holds true for any function. Now, we did linear functions the Thursday before the break. Now we're going to look at some cubic functions. So here we have a cube function and a cube root function. Now, we don't need the table for this because we already know that if we went left 2, we'd go down 8. Left 1, down 1. Right 1, up 1. Right 2, up 8. We know the moves for a cubed function. So let's go ahead and graph this parent graph. On the graph we have right here. And to the best of your ability, draw in the cubic function. Okay.
Did you name it 10 count chicken mini now?
It does take much meat.
Was that it?
You
Is that
did it.
Bill? I thought it was just
It's like a
Chick-fil-A.
box.
That sounds amazing.
That's
Oh.
$50.
No.
Will you not be purchasing that?
No.
I guess
I
I
will
would
not.
but I do know that was just for like.
Why do you not?
How much is it? I don't know. I didn't know it was like.
You can only get this for breakfast. How do you not know this? I feel like I've eaten them for dinner.
Okay. Back to some math. Alright, this is a cube root function, and we know that the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So if we go to graph this one, we'll graph those points. Whoops, wrong spot. Okay, so if we look at these points, if we look at our table, what do you notice? We notice the same thing we already knew. Guys, if you need to talk, you're welcome to leave. There's an open room down the hall, and I'll come deal with you later. It's Miss Fuller's room. We're going to switch the x and y's, which when we look at the graph, this causes a reflection, and it causes a reflection over that line y equals x. We talked about that reflection is also a double rotation over the a double reflection over the x and y. So we should notice that all these points just flip over this line. That's a little off down at the bottom. There we go. So we talked about this before the break. Graphs of inverses are reflections over the line y equals x. I also talk about one other thing, and you may or may not remember this. Yeah, you do. Okay, so these two functions, f of x equals x cubed, and its inverse, they are considered one-to-one. 1-to-1 is the special classification when a graph and its inverse are both functions. And one way that we could have decided that before graphing the second function was to do both a vertical and horizontal line test. If it passes both, then that function is considered 1-to-1, which means the graph and its inverse are both functions. Yes, Sammy?
So is square root the inverse of square?
Does it?
It is.
And
And
why are
we're-
the graphs nowhere like close to each other? Like why do they not?
And we will talk about that. Because Sammy, when we graph an inverse, we switch the x and y. Well, domain is all our possible x values, and range is all our possible y values. So when we look at the inverse, what that does is it switches the domain and range of the original function. And you're right. A parabola and a square root don't look like they've been reflected over that line. Because what happens is, when we look at a parabola, this is a quick little side note. When we look at a parabola,
Oh, it's like the side thing. It's one of
the
the.
domain of this is from 0 to infinity. Which means when I do its inverse, not the domain, excuse me. The domain is negative infinity, positive infinity, but the range is 0 to infinity. So when I do its inverse, they're going to switch. So this becomes the domain.
Is that why it didn't go past the second line?
And this becomes the range. Now, this gives us this,
Not a function.
which is not a function. So to keep this a function, what do we have to do?
Square root then.
We have to put a stipulation.
Again.
Yeah, and we'll talk about that. We didn't do that one today because there's a little bit of extra work to do. Now, on this one, the domain and the range are negative infinity to positive infinity. So when we switch those two, can we tell any difference? No. Yes, sir.
So is that a 1-to-1 graph?
This graph is 1-to-1.
So like is it not past the vertical one?
The blue one and passes the vertical and horizontal. They both pass both.
They don't have to when they're like together.
Oh, it's like separate.
Yeah, you just look at them one at a time. Yeah.
I should be a teacher.
Okay.
I knew what he was thinking.
Now, on your quiz Monday, because of the amount of material on the quiz, we have chosen not to put the graphs on there, just because they take a while. Okay? But the graphs help us with understanding. So we're going to concentrate on the graphs after the quiz some more. So what we're going to practice today is just solving. So this was not yesterday. It was actually the Thursday before the break.
We take notes Friday.
No, Friday was Turkey Day.
Okay, so,
Turkey.
but day one notes were
Day 1 notes on inverses were Thursday.
but we just wrote it on our phone.
Yes, we did.
I stapled the wrong one to my turkey. I stapled the wrong sheet.
You're a turkey.
It looked like the same one.
I did.
I'm sorry.
All right.
Oh, I have to rewrite what I'm thankful for too.
So this is what
Oh no, I
says
don't.
it's
No, I don't. No, I
negative,
don't.
But it's not. They
Okay.
won't.
Give me just a second, and I'm going to go back over the steps. All right. So step 1 is to switch the x and y.
That's probably.
Step 2 is to solve for y. And step 3 is to rewrite using inverse notation. So those were the 3 steps we used when we did inverses of linear functions, which is what we did the Thursday before. Okay, these steps are the same though. We just get there a little differently. So step 1, switch the x and y. So that it becomes this.
Put my nose
Step 2 is to solve for y. So on this equation, what do I need to do first to start solving for y? Add 5 to both sides. That is exactly what we do. So we'll add 5 to both sides. So now we have x plus 5 equals y cubed. We've already talked about what is the inverse operation to cubing? Taking the cubed root. So that is what I do at this point. I take the cubed root of both sides. So now I have the cubed root of x plus 5 is the inverse of y. And so that y inverse, this little negative 1, that is my inverse notation. That's what I change it to at the end when I'm done. Questions? All right, same process for the next 3. Okay?
What's the point of the y minus? Why do you put -1?
Because this little negative 1 means inverse. So that's our step 3.
Okay.
Alright, so step 1, switch the x and y. And then we solve for y. So this one's slightly different. What is the first thing we do in order to solve for y? Subtract 8. So that's very similar to what we just did. Okay, now we have to take the cubed root. So this is now the cubed root of x minus 8 equals y minus 1.
Y minus 1 -1?
Okay, and now what's the last step?
Oh, you gotta add.
Add 1. Move the 1 to the other side. And now we have y all by itself. And once you have solved for y, that is when you use the inverse notation. Once we get y totally by itself, we rewrite the y using inverse notation. Okay, same process. Switch the x and y. Okay, so what do we do here to solve for y? What has to go first? The 1/2. Okay, what do we do when we have a fraction? Multiply by the reciprocal. So everything over here gets multiplied by 2 and everything over here. So this gives me 2x
Y cubed
Inverse. Notation.
not there yet.
I know, we gotta take the cube root
You're right.
of both sides.
Huh?
to tell you, those of you that will show all your steps will get this right. Those of you that try to do too much stuff in your head will miss them and not even realize it. That is not what you want to do, because these are too easy, aren't they?
Too easy.
Okay, so number 4 is a little more complicated just because we have more stuff to undo. So when we switch the x and y, we got to be thoughtful about our undoing process. What do we have to do to properly take the inverse? So what needs to go first? Subtract 10. Perfect. Minus 10, minus 10. Alright, what's next? Divide by 2. Okay, so we can either divide by 2 or multiply by the reciprocal, multiply by 1/2. So if we divide by 2, it could look like this. If we multiply by 1/2, it could look like this. Either way. Or we could leave it 1/2 x minus 5. Look at all those acceptable right answers. All of these are the same, aren't they? I kind of like this one because if we leave it this way, when we take the cubed root next, we can still see that horizontal shift. Now you can see the horizontal shift here too. It's harder to see the horizontal shift here because remember, with a horizontal, this coefficient has to be factored out. So I really like this one or this one the best, but this one's right too. All 3 are correct. Okay, so let's see what it would look like when I take the cubed root here, or the cubed root here, or the cubed root here. That's what they look like. Now all those are right. Every one of them. And so the last step would be to move the 2 over. So one acceptable answer would be this. Yeah, we would have to subtract 2. Another acceptable answer would look like this.
My answer is accepted.
And the final acceptable answer would be this one. So all of these are right. That's not a 16, that's a 10. It's just a rough looking 10. There we go.
Yeah.
So whichever one you like the best, all 3 of those forms are right. So that one's right. This one's right. Or this one.
Why would you distribute why would you use that? Like when you do y cubed, why would you do y cubed plus 8?
Y plus 2 cubed.
Yeah.
Because if we cubed it, we'd have to write out y plus 2 3 times and do a ton of distributing.
So instead you just put y cubed plus 2.
Yeah. If we cube that, do you remember,
Yeah, cube root.
have we done Pascal's triangle in here?
Yes.
Yes, that turns into be the 3rd row of Pascal's. 1, 3, 3, 1. So it's y cubed.
So wait, how does it work? How does that work?
It's
You just want y cubed plus
No,
2.
Okay, you just want to leave it like this. You don't want to cube that. Cubing it is bad. And it takes it out of your graphing form and puts it in the other form. Alright, so those were our 4 examples on how to take a cubic function and write its inverse, which is cubed root. Well, now we're starting with cubed root, so what will its inverse be? Cubed. Okay, so same steps. Switch x and y. Subtract 2. Solve for y. we don't really want to cube that. Just write it as x minus 2 cubed. So we know we shift right and 2. We're not there yet. Thursday is December 1st.
Mass, and then Friday's the second.
Correct. Yeah.
That's when they put out white water.
Noonan, you said, right?
Next week, yeah.
Cougars.
So you can, well, the week before, exam.
Okay.
Okay.
Alright, number 6. Switch to x and y. Solve for y. So this one's a little easier because we cube right off the bat. And so we get x cubed equals y minus 4. And then we just move the 4 over. Okay, we're going to skip number 7 because number 8 kind of covers what number 7 would have done anyway. And so let's do it. We switch to x and y. Alright, on number 8, what's got to go first? The 3. So we'll subtract that 3 to move it to the other side. Multiply by 2. Okay, so just leave that 2 out in front. Because it actually makes it easier for what comes next. So if we leave that 2 and we don't distribute it, our next step is to cube. Okay? So Zach, this is kind of important. Leave that 2 out in front because it makes it easier. Because right here we have to cube and we have to cube. So the 2 gets cubed and makes 8. And then the x minus 3 has to get cubed. And so this gives us 8 times x minus 3 cubed plus 1 is the inverse.
Wait, you scored.
Oh, I did. That should be a cube.